Hi, Mr. Causey here. In this question we're given a triangle and we're asked to find the equation of L1, which is the perpendicular bisector of PQ. Now that means that it's at right angles and it chops this line PQ into two parts. Let's call that midpoint M. So let's see if we can move forward with this. Remember, to find equations of straight lines, we would use the formula y minus b equals mx minus a, where m is the gradient and AB is a point that lies on the line. So what do we know so far about L1? Do we know the gradient? Well, no we don't, but we know it's perpendicular to PQ, and there is a result that says if we know a gradient is AB, for instance, then a gradient of a line perpendicular to that line would be b over a with the sign change. So we invert the fraction and change the sign. So that's something we could do. First of all, we would have to find the gradient of PQ. Now we do know 2 points on the line PQ, so it's the y difference over the x difference. So let's start with the point P. That's 4 minus -2, the difference of the two y coordinates, divided by 3 minus 9, that's the difference of the two x coordinates. So that's 6 over -6, that's -1. And certainly that line PQ, along one, down one, that's looking okay for a gradient of -1. So if we assume it's -1 over 1, when we find the gradient of a line perpendicular to that, we'll invert the fraction. That makes no difference really, it's just still 1 over 1, and change the sign so it becomes +1. And looking at L1, that looks like a gradient of 1 along, 1 up. So we've found the gradient of line L1. Do we know a point on the line L1? Well, it has to be point M, which is the midpoint of PQ. So also M, and how do we find the coordinates of M? Well, we average the two x's, find the mean, that's 3 plus 9 divided by 2, that's the mean of the two x coordinates, and the mean of the two y coordinates, add them up and divide by 2. So M is the point, 12 over 2 is 6, and 2 over 2 is 1. M is the point, 6, 1. So we know various facts now. The gradient of L1 is 1. A point on L1 is 6, 1. So we're in a position where we can now use this y minus b equals mx minus a formula to find the equation of L1. And that'd be y minus b, y minus 1 equals m, which is 1, times x minus b, x minus a, which is 6. So that gives us y minus 1 equals 1 lot of x minus 6. Let's add 1 to both sides. Y equals x minus 5. So y equals x minus 5 is the equation of that line. Now what I think we should do is to use the diagram at the very end of this question and add these pieces of information as we go. So we're wanting to transfer the fact that we know the equation of L1 is y equals x minus 5 onto that final diagram. So there's the final diagram, and let's add y equals x minus 5 onto that. Moving on to part B, calculate the coordinates of C. That's the point of intersection of L1, which we've already found the equation of, and L2. Now they're telling us that L2 is also a perpendicular bisector, but this side of side PR, and its equation, we're told, is 3y, let's put that on the final diagram, 3y plus x equals 25. And we're asked to find the point of intersection of these two lines. That's this point here. So for the coordinates of the intersection, we must solve these two equations. These two equations must be both true for the point C, so we'll solve them simultaneously. So we'll solve y equals x minus 5 and 3y plus x equals 25. We'll solve this system of equations, solve them simultaneously. Now, because we know y equals x minus 5 must be true, and we also know 3y plus x equals 25 must be true, we can replace y in this second equation by the x minus 5 of the first equation. And that allows us to find the value of x. Let's get rid of the brackets. So 3x plus x is 4x, and add 15 to both sides and we'll get 40. So therefore x equals 10, and y must be equal to, let's use x minus 5, so that's 10 minus 5, which is 5. So that leads us to the conclusion that C is the point 10, 5. And let's go up to this diagram and just add that information to it. So there's C is the point 10, 5. So finally, part C. In this case, we have to determine the equation of the circle. So, circle. We know the centre of the circle is 10, 5. We would also have to find the radius of the circle. Now, the radius of the circle would be the line going from P to C. Let's do that, P to C, because we know that's 10, 5. We could certainly work out that distance, and we know the centre. So let's work out that. The radius, let's work out the length of that radius. The radius is PC, and distance formula, x difference squared, 10 minus 3 squared, plus the y difference, 5 minus 4 squared. That's using the distance formula. So it's the square root of the x coordinates, the difference of them squared, plus the y coordinates, the difference of them squared. So we've got 7 squared plus 1 squared. That's the square root of 50 for the radius of the circle. And the centre of the circle is 10, 5. Now, there is a result about circles that if we have a radius r and we've got a centre AB, then the equation of the circle is x minus a all squared plus y minus b all squared equals r squared. So in this case, the equation of the circle is x minus 10 all squared plus y minus 5 all squared equals the radius squared, and if we square the square root of 50, we get 50. So that's the equation of this circle. So that's Mr. Carsey signing out, and thanks for watching this video.